Hey everyone, welcome to another episode in Physics is Fun. Today is going to cover a complex 2D kinematics problem with only variables. Let's jump into the question. A friendly neighborhood escapee monkey is on the ground inside its cage that has a height of h sub c above the ground. Finishing a rather satisfying banana, it throws the banana peel vertically upward, starting from rest, by pushing the banana peel over a distance of d sub bp at a constant acceleration of a sub bp before it leaves the monkey's hand. The banana peel leaves the monkey's hand at a height h sub h above the ground. Express all answers in terms of the variables given and fundamental constants. A. What is the velocity of the banana peel as it leaves the monkey's hand? B. What is the maximum height reached by the banana peel above the ground? Let's draw a picture. The monkey is outside the cage with the height h sub c. The monkey accelerates its arm across some distance d sub bp with some constant acceleration a sub bp. The banana leaves the hand at a height above ground of h sub h. The monkey and banana are on Earth, and so always note that gravity affects them at constant negative g. This question looks complicated, but if you are able to draw a really good picture, it should really help visualize that there are two halves to this problem, and it is all 1D kinematics. After I draw a picture, I look and note down some of the things I notice. The question asks what the velocity is when the monkey lets go, so the velocity initial at height h sub h. Also, the other half has the distance d sub bp, where there is a start and end, the end being h sub h. So the velocity final at dbp must overlap and be the initial velocity as well. Velocity final at distance d sub bp will solve part A. Write some variables in terms related to the basic equations. The distance initial is the start from rest, so is 0. The distance final is the distance d sub bp. The acceleration is a sub bp. The monkey's hand starts at rest, so the velocity initial equals 0. Finally, the velocity final of this distance is unknown, but what we are looking for. We do not have time given at all, so the equation without time lines up with the variables we have, and so we can solve now using velocity final squared equals velocity initial squared plus 2 times acceleration times x final minus x initial. Let's calculate. Rewrite velocity final squared equals velocity initial squared plus 2 times acceleration times x final minus x initial. Just need velocity final, not squared, so square root both sides, and velocity final equals square root velocity initial squared plus 2 times acceleration times x final minus x initial. Plugging numbers in to get velocity final equals square root of 0 squared plus 2 times a sub bp plus 2 times a sub bp times d sub bp minus 0. Simplify to get the answer for velocity final equals square root of 2 times a sub bp times d sub bp. We solved part A. Let's write in velocity final equals square root of 2 times a sub bp times d sub bp. Moving on to part B, again writing some thoughts. What does max height mean? I make a height variable called h sub max to solve for, and we know the banana peel leaves the monkey's hand at height h sub h, so the initial height is h sub h. I also note a height final above the ground will equal height max of the banana peel plus the height h. Thinking of the max height of projectile, the velocity must equal 0 meters per second. Also, our velocity initial for this half will be the velocity final from part A. This helps me put out all the info I know or could want for the possible question. So, looking at what we have of a height, x initial, and acceleration from gravity, and both initial and final velocities, and we want a height max, or the x final, and again with no time variables, so using velocity final squared equals velocity initial squared plus 2 times acceleration times x final minus x initial. Part B is ready to solve for. So let's calculate. Rewrite velocity final squared equals velocity initial squared plus 2 times acceleration times x final minus x initial. And let's start to solve for the x final. Subtract velocity initial squared from both sides and cancel on the right side. Now with velocity squared minus velocity initial squared equals 2 times acceleration times x final minus x initial. Divide both sides by 2 times acceleration and cancel on the right side. Finally, with velocity final squared minus velocity initial squared divided by 2 times acceleration equals x final minus x initial. Add x initial from both sides to isolate x final and cancel on the right. This leaves x final equals velocity final squared minus velocity initial squared divided by 2 times acceleration plus x initial. Plug in numbers to get x final equals 0 squared minus square root of 2 times a sub bp times d sub bp, all squared, divided by 2 times negative g plus h sub h. Simplifying, we get x final equals negative 2 times a sub bp times d sub bp divided by negative 2 times g plus h sub h. Negatives become positive and the 2's cancel to leave a final answer of x final equals h sub h plus a sub bp times d sub bp divided by g. Whew. So after reading a long problem with no numbers at all, we drew a nice little picture that clearly showed the two halves of this problem. Part A, using the givens to find the velocity final over the distance d sub bp equals square root of 2 times a sub bp times d sub bp. This gave us a velocity to start with to find the max height. The banana peel goes, which is x final equals h sub h plus a sub bp times d sub bp divided by g. I hope these intro problems are as helpful for you as they are for me. Thanks so much for watching. Hope you come back to learn more exciting material, and see you next time.